All right, in this video, we're going to go over linear functions in slope-intercept form. All right, here's your vocabulary. Slope. The slope of a non-vertical line is the ratio of vertical change to the horizontal change between 2 points. Linear function, a function whose graph is a line. Linear equation is a representation of a linear function such as y equals 6x minus 4. Make sure you write that down. Pause the video if you need to. All right, here's a little concept summary of slope. Positive slope. Just imagine yourself walking along this line. All right, if you were to walk along this line, your altitude would be going up. So since your altitude is going up, that is a positive slope. Same thing here. If you were walking along this line, you would be walking down. Your altitude would be going down. Now, zero slope and undefined slope, those are concepts that sometimes are difficult to remember which is which. Well, again, just remember you're walking on it. If you're walking along this, your altitude's not changing at all. So that's a zero slope because nothing is changing. But now, undefined slope, you can't walk straight up the side of a building unless you're Spider-Man, okay? And I don't think any of us are Spider-Man. So, undefined slope you cannot walk on. A zero slope, a negative, and a positive slope, just imagine yourself walking on them, and the slope is doing the thing, same thing your altitude would be doing. Here you'd be going up, here it's down, and in here it's not changing or zero. All right. Now, let's look at some problems with slope. Now, if you remember from past, from geometry, slope is rise over run, or the change in y over the change in x, or it can be called delta y over delta x. All right, and of course it's simply y2 minus y1 over x2 minus x1. That's all it is. So if we wanted to find the slope between point -3, 7 and -2, 4, all right, you just pick a point to be 2, pick a point to be 1. I'm going to do this 2 and this 1. So we're going to do y2, which is 7, minus y1, which is 4, over x2, which is -3, minus x1, which is -2. And of course, a minus and -2 is a plus 2. So 7 minus 4 is what, 3? And then -3 plus 2 is -1, which gives you a slope of -3 over 1. Because if you remember, it is not proper to put your negatives in the bottom. You either put them out in front of the numerator or out in front of the fraction bar completely. So, now with slope, you can always leave it as a fraction, -3 over 1. I'll take that as a completely acceptable answer in reduced form. All right? Because if you just wrote this as -3, well, since it's rise over run, leaving out the over 1, you're really kind of leaving out your run. So you can leave it like this if you want to. All right, let's try another one. Let's find the slope between 7, -3, and 7, 1. All right, so I'm going to pick this to be 2 and this to be 1. So we're going to have y2, which is 1, minus y1, which is -3, so that's plus 3, over 7 minus 7, which gives us 4 over 0. Can we divide by 0? No, this here is undefined, which means we have a vertical line. Okay, so anytime you divide by 0, you get undefined because you can't divide by 0. Things blow up when you divide by 0. So you would have a vertical line. All right, it's not no slope. It's a vertical line. If the 0 had been in the top, then it would be no slope, which would be a horizontal line. But since the 0's in the bottom, it's undefined and it's a vertical line. All right. Moving along. Slope-intercept form. Okay. Slope-intercept form of the equation of a line is y equals mx plus b, where m is the slope of the line and 0 comma b is the y-intercept. All right, so y equals mx plus b. So let's look at a problem. Say we had, it says write an equation for the line where m equals 1 over 5 and the y-intercept is 0, negative 3. All right. Well, we know the y-intercept is negative 3. We know the slope is 1 over 5, so we have m, we have b. We just simply fill it in, 1/2 x, and then plus negative 3 or just minus 3. Now, this can also be written as y equals x over 2 minus 3. It doesn't matter if you put the 1/2 in front of the x or if you put the x in place of the 1. It's the same thing, and you may see it written this way more. I'm not sure with this new book, but this is the way I usually write it. All right. So let's look at a different one. Say we had an equation like this: 5x minus 4y equals 16. And we want this written in slope-intercept form, which means we have to solve this equation for y. So you just simply start solving for y. So we need to move the 5x over to the other side. So minus the 5x minus 5x. So negative 4y equals negative 5x plus 16 to keep it in the mx plus b format. Then, of course, we have to divide off the negative 4. So y equals negative over negative is positive. So 5/4 x, and then positive divided by negative is a negative. So that would be y equals 5/4 x minus 4. And again, you could also put the x in the top, which would be 5x over 4 minus 4. Okay? Either way is right. It doesn't matter which way you do it. Okay? All right, I think that's enough on slope-intercept. Let's look at graphing a line in slope-intercept form. All right, so let's graph this line. Negative 2x plus y equals 1. All right, first thing we want to do is we want to get it in y equals mx plus b format. So we're going to we want the y by itself, so we need to move the 2x to the other side. So y equals 2x plus 1. Remember, this is 2 over 1. Now, all you'd simply do is this. This is your y-intercept. Okay, it's going to intercept the y-axis at 1. So you go to your graph and you put a dot at y equals 1. Okay, so 0, 1, there's our y-intercept. Now, you can simply, since slope is rise over run, you can simply count up to 1, 2, and then to the right 1. All right, and then you just connect your dots. If you want it to be more accurate, you can do it again. You can put as many points as you want, as long as you follow the 2 over 1 slope. And then, of course, you just connect the dots. Hopefully you connect them a little better than I just did. All right. So when you have slope-intercept form, you simply plot your y value, your b value, which is your y-intercept, and then you count up and over for your slope. If this had been a negative, you would have counted up and then go to the left. All right. If it's all positive, it's up and to the right. If it's negative, it's up and to the left. All right. So let's graph one more line, and then we're going to call this video a wrap. All right, let's graph 4x minus 7y equals 14. You know what? Pause the video and try this yourself real quick. All right, so we want to get the y by itself, so we're going to subtract the 4x from both sides. Negative 7y equals negative 4x plus 14. Divide negative 7, divide negative 7. Y equals negative over negative is positive. And then that would be minus 2. So we know our y-intercept is negative 2, so that's right here. And then up 4, 1, 2, 3, 4, over 7. 1, 2, 3, 4, 5, 6, 7. And connect That's what your line should look like. And that's what your equation should look like. All right, so that's it for linear functions in slope-intercept form. So make sure you understand the concepts in the video and come tomorrow ready to work some problems. See you tomorrow.